Today, we're going to talk about something, well, something that might just change how you think about math itself. We're diving into the work of Mike Tate, who's proposing a system that asks us to completely rethink what a number even is. So, let's start with a crazy question. What if numbers, 1, 2, 3, what if they weren't just abstract concepts we made up? What if they were real?
And I mean really real. Like, what if they were actual particles of information, little bits of reality that have properties you could measure? Things like a position, a spin, even energy. It sounds like science fiction, I know, but this idea is the key to this whole new universe we're about to step into.
Now, you might be asking, why do we need a new universe for numbers? Isn't math doing just fine? Well, to get why someone would even suggest something this radical, you've got to understand that modern mathematics is staring down some truly gigantic problems. Think of them as the Mount Everests of math. You've got things like the Riemann hypothesis, this deep, dark mystery about the secret pattern of prime numbers that's been stumping the smartest people on Earth for more than 150 years. Or P versus NP, which basically asks, is it actually harder to find an answer than to just check if an answer is right? And listen, these aren't just puzzles for academics. With quantum computers on the horizon, the answers to these questions could break all of our current cryptography. We're talking global security here. So, when you're up against walls that high, walls that generations of geniuses couldn't climb, you have to start wondering, are we just not hitting the wall hard enough? Or are we using the wrong tools entirely? And that is the absolute soul of Mike Tate's work. The whole point isn't to build a bigger, stronger hammer to just smash through these problems. The idea is to craft a new kind of lens, a new way of seeing, so we can spot a door that's been hiding in plain sight this whole time. And you know what? The key to that door is surprisingly simple. It's called modular arithmetic, but trust me, you already get it. It's just clock math. If it's 10 o'clock and you add 4 hours, it's not 14 o'clock, right? It's 2 o'clock. The numbers just wrap around. This one simple idea of a looping, finite system is the bedrock for this entire new way of looking at numbers.
All right, so let's take that clock math idea and start building. Let's actually construct this new universe where numbers aren't just marks on a page anymore. They're living, breathing, dynamic objects. So here's the fundamental shift in thinking. We're tossing out abstract symbols and replacing them with what Tate calls number particles. Suddenly, every number becomes its own little atom of information. It's a fundamental piece of the puzzle with its own identity, its own properties, just like a particle in physics. And what defines these particles? Well, it's a triad of 3 core properties. First up, you've got its position. That's easy. It's just its address on our number clock. Is it at the 4 o'clock spot or the 9 o'clock spot? Then there's its symmetry. This is kind of like its internal spin. It gives the number its unique flavor and dictates how it behaves around other numbers. And finally, there's its energy, which is wild. It's like a memory, a historical charge that keeps a record of everywhere that number has been. Okay, so you've got a universe full of particles. What do you need next? A rule book, right? Its own laws of physics. And in this world, that rule book has a big name: symbolic renormalization field theory. Forget the name for a second. Just think of it as the grand blueprint that says exactly how these number particles are allowed to talk to each other, how they resonate, and how they combine to create everything we know as math.
Which leads to the million-dollar question. So what? Does this fancy new language built on particles and resonance actually help us with those impossible problems we talked about? Well, let's take another look at those big, unscalable walls, but this time through this new harmonic lens. Let's start with the big one, the Riemann hypothesis. In the old view, mathematicians are basically hunting for these mysterious little points, these zeros, on an infinite line. It's a search. But in this new harmonic view, it's not a hunt at all. It becomes a problem of resonance. It's like plucking a guitar string. Those points aren't hiding. They're just the natural notes that the number system wants to sing. Or how about Goldbach's conjecture? The idea that every even number is just 2 prime numbers added together. The old way to prove this is basically an endless guessing game. But here, it transforms into a waveform synchronization problem. The prime pairs aren't found by chance. They just emerge when their symbolic waves naturally sync up and resonate with each other. And P versus NP. We usually frame this as a problem of time, how long a computer takes to find a solution. This framework flips it completely. It's not about time, it's about order versus chaos.
The theory suggests that for any ridiculously complex problem, there's a unique harmonic frequency. And if you can just find that frequency and play it, the insane complexity just collapses. It folds in on itself, revealing a beautifully simple answer.
Look, what's so important to get here is that this isn't just about finding clever tricks to solve old puzzles. This is a proposal for a fundamentally different way to do math. It's a whole new architecture for how we think.
One of the papers on this is called Bridges Without Nails, and I just love that image. It paints this picture of a mathematical world held together not by brute force, not by hammering rigid proofs together, but one that stands on its own, through perfect balance, harmony, and resonance. And that image really gets to the core philosophy here. It's all about moving from static, black and white proofs to dynamic, colorful visuals. It prefers elegant, repeating patterns over just brute force complexity. And it's built on the idea of sharing these tools freely, not locking them up in ivory towers. It's really a quest for elegance and coherence over all else. Honestly, this one quote about Goldbach's conjecture pretty much sums up the entire worldview. The prime pair is not chosen, it resonates. In this universe, mathematical truths aren't things you just stumble upon by accident. They are things that emerge from a deep structural harmony. They literally resonate themselves into existence.
So that brings us to the end, and one last big question. We've seen this incredible new architecture. We've glimpsed its potential. But where does that leave us? Is this really it? A true peek into the future of mathematics? A way of thinking that's more intuitive, more visual, more connected to the physical world? Or is this just a profoundly beautiful, intricate idea that is now staring down its own unscalable wall? The wall of formal, rigorous proof that the rest of the mathematical world demands. The truth is, we don't know the answer yet, but the view from this side of the wall, it's undeniably powerful.